Welcome to the DTM lesson. And so once again, you should be taking notes as you watch the video. And anytime you see something in yellow that is on the screen, you should definitely write it down. So today we're going to talk about particularly a little bit of a tricky concept. So the demographic transition model. And so the big question today is, why did the world population explode in the past 200 years? So we are going to, by the end of class, be able to describe the population explosion and explain what happens to birth rates, death rates, and population growth during the demographic transition. So really quickly, just to get a little context, this is our world population growth from 1750 to 2100. For most of human history, world population was really, really low. And starting around the 1750, about 1800, starts to grow. And it grows at a pretty slow pace until probably about 1950, 1960. And at that point, we start to see this population explosion. It absolutely goes out of control. And so many people really were alarmed and really started to predict this early on, but really, really alarmed with that population growth. So my parents were born in 1952 when the world population was probably about 3 billion people. And by 2000, that world population had doubled. So my parents' lifetime, it's more than doubled. And interestingly enough, this year, or actually 2022, so last year, in November 15th of 2022, our world population reached 8 billion people. So here we are right here, 8 billion people. You'll notice, though, that our world population does not look like it is going to continue to grow indefinitely. It's not going to continue going up on this upward trajectory. Most people believe that our world population will eventually even out around 10 or 11 billion people. So as I just noted, you should write this down. World population was low and had really low growth for much of human history. Starting in 1800, the world population started to grow exponentially. And the demographic transition model, which is what we're going to talk about today, explains this growth. Okay, so right now, pause your video and write down the things that you see in yellow. All right, for a title today, you are going to write the demographic transition, and we are going to go through the demographic transition model and talk about what this whole thing is, and then you're eventually going to draw it out. So the first question is, what does demographic mean? What does transition mean? So the word demographic, when we use this term, we really just mean relating to population. So we have demographic relating to population. So if we have a demographic transition is the process of changing from one condition to another. So the demographic transition is really this idea that population is changing from one type of population to another, or maybe one growth rate to another. So demographic transition is the process of changing from one population type to another. So I'm going to go over an activity. You can kind of follow along with me. And if we were in class together, I would ask you to take out a blank sheet notebook paper to draw a large circle, which I'm going to show you in a moment. And this circle is going to represent a society. You're going to draw 10 stick people in the middle. And these are these are your society's people. And then I'm going to ask you to draw or subtract. So if you want to kind of follow along with me, I am going to draw a large circle. Oops, that's not very good. Let's erase that guy. Okay, let's try this again. Okay, so I'm going to click that way. Okay, let's try this again. All right, so I'm going to draw a really large circle. Whoa, you can see that that circle is not very good either. All right, doesn't matter. All right, so I'm going to draw 10 sick people, and I'm just going to draw faces because I'm going to be doing this quickly, but if you were in class or if you're doing it right now, you might want to draw real stick people. Okay, so here's 10 people. All right, so we have a society. Our society exists of 10 people, and the next slide, they're going to ask you to add or subtract people by adding or erasing. Okay. So in stage 1 of our demographic transition model, we have traditional societies. For the most part, people were hunters and gatherers. There was, and in hunting gathering societies, there were a lot of babies being born. So I'm going to add 20 people to my population. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Oh my gosh, look at all those babies being born. That is a lot of babies. However, in this society, many of those babies do not survive. So I'm going to kill off 10 babies, mostly because the infant mortality rate was just really high. 2, 3, 4, 5, 6, 7, 8, 9, 10. So our society is still bigger than it was before, but there's a lot of other causes of death, like disease, 1, 2, 3, 4, 5, that cause people to die every year. And then war and famine. Famine is not enough food to eat. 1, 2, 3, 4, 5. So in these hunting and gathering societies in stage 1, populations would rise because a lot of children were born, but they would also fall quite a bit too due to really high death rates. So in general, population stayed relatively steady. In stage 2, people start to settle down into farming communities. Populations slowly grow, but death rate is still really high. Farming families had lots of babies because they were assets that could help people out on the farm. So we're going to draw lots of children being born in agricultural societies. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And children in farming communities are big assets because they're helpers on the farm. And around the 17 to 1800s, farming practices are going to improve drastically, and farms are going to grow enough food that they can sustain people throughout the famine. So infant mortality and death rates decline drastically when we have people that are fed. So babies still do die. 1, 2, 3, 4, 5. And people die of other causes like infectious diseases and old age. But you'll notice that our overall community is starting to grow because there are more children born every year than there are people dying. In stage 3, agriculture is going to improve. Not everyone in society is going to have to be farmers, so they start to move to cities. And with this shift, birth rates begin to decline as children are not as much of an economic advantage. But there's still a lot of children that are going to be born. So babies are still going to be born, and but not as many as before. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. But there starts to be more advancements in medicine and in things like antibiotics and penicillin. Vaccines are invented to cure infection and prevent infectious diseases. So more babies do survive. Because of this, the infant mortality in this community that we have here is we're just going to have one child that doesn't make it. The death rates decline. 2 die of disease, 1 die of cancer. As people move to cities, there's more crime in cities. So we do have people who are dying every year. 1, 2, 3, 4. But you'll notice that this community has really, really grown because there are still a lot of children being born, even though it's not quite as many as before. But the death rate is pretty low. And so that's a positive thing, right? Death rate is pretty low. But in general, that is going to cause populations to boom, to really, really blow up. So in the city, more children become a liability than an asset. So in stage 4, children become really expensive. So the total fertility, which is the number of babies per woman, gets closer and closer to 2. Infant mortality rates are going to be very low in this population, and people live much longer, and they die of degenerative diseases. So babies are still born, but just not nearly as many as before. So we're going to give 7 babies birth. 1, 2, 3, 4, 5, 6, 7. And the people are dying of older diseases, so like Alzheimer's and heart disease and cancer. We are going to have a death rate here of 5 in this population. 1, 2, 3, 4, 5. And part of that is just because people are getting older. Okay, the last stage of the demographic transition model is going to be stage 5. In the final stage, education, particularly those of women, is very high, and careers are oftentimes a priority rather than starting a family. And as marriages happen later and later, women wait to have children, they have less and less. So women are having very few children in this society in stage 5. So we're going to have 2 children that are born. But because this is an elderly society, we are going to have a large chunk of our population that is old. And because of that, people are living to old age, but eventually everyone does die. So we're going to, because we have such an elderly population in this society now, 5 people do die. And so overall, if we think back to the beginning of this activity, we had 10 people in our population. But as we have transitioned through different stages, our population has grown overall. And this is going to be the essence of the demographic transition model. So what happened to our overall society from beginning to end is that it did grow. Birth rates started off really, really, really high and eventually declined to the end. Death rates do start off pretty high in stage 1, but they also decline. And then how does this relate to our world population? Okay, so as we were talking about before, world population was very, very low, just like in stage 1 for a very long time. And then population really did start to explode as we moved through stage 2 and stage 3, and then the demographic transition model. Okay, so here we're going to come back to the model. So in your notes right now, you should have a couple notes already written down, but you should write or rewrite the demographic transition model, and then you're going to draw this out. So you don't have to draw out everything, but you should have this axis here, this axis here. You should separate your chart into, over here you should write birth rate and death rate. And then over here, you're going to have just time. So this is going to be as we progress through time. So then you're also going to separate your chart into stage 1, 2, 3, 4, and 5. And with that, you are going to have death rate and then birth rate. So in stage 1, death rate and birth rate are both very high. And when death rate and birth rate match up, we're not going to have very much growth, which is why we see low growth here. In stage 2, you're going to have a high birth rate because we're still agricultural, but death rate begins to decline because people are better fed. Then we're having stage 3, people start moving to cities, they start having less children. Death rate continues to decline with modern medicine. And in stage 4, kind of at the end of stage 4, those death rates and birth rates start to match up again, but they match up at lower rates than they did over here. Over here, they were kind of matched a little bit. We have low growth, but down here, they're both very low. In stage 5, eventually, birth rates are actually going to fall below death rates, so we're going to have declining populations. So now we're going to go through each of the stages. You should, once again, have these notes on your demographic transition model. I am going to attach a sheet that shows you those stages of the demographic transition model. If you want to either print it out or if you want to type in it, you can use it to type. But you're going to have stage 1. You're going to have these are going to be the characteristics of stage 1. High birth rate, high death rate, low natural increase rate. You can write that below stage 1. Stage 2 is here, so you're going to have these as your characteristics. And you can write that below stage 2, and here are the causes. Stage 3 is going to be here. Here are your causes, so as we talked about. You should write that below your notes in stage 3. Stage 4 is here. You're going to write these as your characteristics. These are your causes as stage 4. And then stage 5 is going to have low birth rates. Birth rates are lower than death rates. Negative natural increase rates, so populations are declining. And then these are the causes here. Okay, so we are going to that is where you're going to end for today. And please reach out to me if you have any questions on the demographic transition model.